Hello everybody. Usually inverse functions aren't too difficult for people. It's just a matter of understanding the notation. So hopefully this shouldn't be too bad. Okay, so inverse functions. Two functions, we'll call them f and g, are inverses if the following hold. If you put g into f and simplify, you get x. And if you put f into g and simplify, you get x. So if you can plug one function into the other in both directions and they simplify to x, that means they're inverses. To indicate inverses, we say f negative 1 as the exponent of x is read f inverse of x. That's how it's read out loud. And just because this is function notation, this does not mean 1 over f of x. It's different notation, so it doesn't, it's a notation, not an exponent. It's just how it's written. If things are inverses, what that means is that they are reflecting across the line y equals x. So you can see y equals x is labeled, and they reflect a mirror image across that line. That's how you know they are inverses. And what that means is basically the x and y values flip-flop. So your x becomes your y and your y becomes your x. And that property is how we're going to find the inverse function. To understand inverse and to be able to find the inverse, you need to understand one-to-one functions, because you can only find inverses of functions that are one-to-one. So a function is one-to-one when each value of the dependent variable, that's y, corresponds to exactly one value of the independent variable, x. And it has to be a function, which means each x goes to y. So basically, if each x goes to one y and each y goes to one x, then it's considered one-to-one because it's a function in both directions. That's the key. It's a function in both directions. My video on functions, I had an example about grades in the class, like your numerical score and your letter grade, and that is not one-to-one because it's not a function in both directions. Now, the horizontal line test is very similar to the vertical line test. So the vertical line test determined if something is a function, and because we're switching the x and y, then the horizontal line test would see if it's a function in the other direction. So if something passes the vertical line test and the horizontal line test, then it is one-to-one, and then that means you can get an inverse. So just to draw some examples here. Let's see. So I'm going to do different colors here. Let's say I have, I did not mean to do highlighter, but that's okay. I thought I was clicking on the pen. So if you have something, the u, that is a quadratic function, we learned about that shape. That is a function because it passes the horizontal line test. But it is not a function in the other direction. It does not pass the horizontal line test. Because if let's choose a different color here. If I draw a horizontal line, I am touching the graph twice. So this is a function, but it is not one-to-one. And that means we can't find an inverse. It does not have an inverse because it fails the horizontal line test. Now, an example that would pass the horizontal line test and the vertical line test would be something like we've seen the cubics. So those pass the vertical line test and the horizontal line test. And so a cubic, it does have an inverse. So this is a function, and it's one-to-one. And then because of that, it has an inverse, and we can find the inverse. Now, if we really, really wanted to find an inverse for our quadratic on the left, what we'd have to do is restrict the domain. We'd have to restrict the domain to look at a certain section that would pass the horizontal line test. So maybe instead of looking at the entire graph, we looked at just the right side. That would make it past the horizontal line test and vertical line test, so that would have an inverse. So we could say, okay, we're going to only look at the positive numbers. But if you don't restrict your domain and you look at everything, it's not one-to-one, so there's no inverse. So because the whole idea of an inverse is that you're flipping the x and y, that's essentially exactly what we're going to do. So first we have to figure out, does it have an inverse? Because if it doesn't have an inverse, then you're not going to do the work to find an inverse. If you've determined it passes the horizontal line test and the vertical line test and it has an inverse, so then you can find the inverse. So to do that, you replace f of x with y. So remember my video on functions, f of x and y are the same thing. So you're replacing f of x with y. And then you're flip-flopping x and y. So everywhere there's an x, you put a y. Everywhere there's a y, there's an x. So you're switching them. Then you solve for y. And once you've solved for y, then you replace y with the notation for f inverse of x. And then you should double check that when you do the function composition, you do get the same thing out. And what's really neat about inverses is that the domain of f is the range of the inverse, and the domain of the inverse is the range of the original function. So they've got this because they're flip-flopping the x's and the y's, so the domain and ranges are like flip-flopped. So I've got a few examples here. And so this first one, example 1, we have a cubic. So I said that a cubic does have an inverse. All cubic functions, well, I shouldn't say all, most cubic functions will pass the horizontal line test. This one has a function transformation where it is it's shifted up. Sorry, I'm having issues where like I'm not looking at my pen is not showing up. This is shifted up 8, so our cubic will look roughly like that. So this is where knowing transformations is helpful because it gives you an idea of what it looks like and whether it's going to be it is one-to-one. So that's just shifted up 8, so that is one-to-one, and so it does have an inverse, and we can find the inverse. So the first step is to replace f of x with y. So I have y equals x cubed plus 8. Then you flip-flop the x and the y. So then we have x equals y cubed plus 8. And now you solve for y. So I'm going to start by subtracting 8 from both sides. So I have x minus 8 equals y cubed. And then to get rid of the cubed, I want to take the cubed root. And so the cubed root of x minus 8 is equal to y. And then you can replace y with f inverse of x. And that is the inverse function. So you replace f of x with y, interchange the x and the y, solve for y, and then replace it with the inverse symbol. So now next is to find the domain and range of both the function and its inverse. So I'm going to use D and R to basically abbreviate domain and range. So our cubic function has a domain of all real numbers. That's negative infinity to positive infinity. So that is listed in the textbook when you learned about a parent function. And it's also on the printout that says a library of parent functions in the weekly content. So that gives you the domain. So the domain of the original function is equal to the range of the inverse function. So that means the range is all real numbers from negative infinity to positive infinity. Now, we can also figure out the range. The range of a cubic is also all real numbers. Again, that's in the same material where it lists the domain. And so that means that is the domain of the inverse function. So if you know one, you can find the other, and vice versa. I don't know why my lines are not straight today. So that's an example. And now let me move on to example 2. Here we have a rational function. And so if you want to make sure that it has an inverse, you can, let's see, I'm going to eyeball this. So it's going to look, I believe it's going to look something like this. It does pass a vertical line test and the horizontal line test. So that is 1-to-1, and so we can find the inverse. So start, oh, I keep accidentally, there we go. Okay, so we start, we've got h of x equals x minus 2 over 3x plus 5. We're replacing h of x with y. So y equals x minus 2 over 3x plus 5. Now you interchange the x and the y. So x equals y minus 2 over 3y plus 5. Now I need to solve for y, and right now I've got y inside a fraction. So in order to do this, we first need to multiply both sides by the denominator so that I can remove, oh, that's a bad color, that's not going to show up. So I can remove at least the fraction, and it will make it a little bit easier to manipulate. So I'm going to multiply both sides by our denominator. So that gives me 3xy plus 5x equals, and then the fraction disappears. That's why we multiplied by the denominator, so we just have y minus 2. Now, if I want to solve for y, I need to get everything with y in the same side. So I'm going to subtract y from both sides. So this gives me 3xy minus y plus 5x equals negative 2. And now I'm going to move what does not have a y to the other side. So I'm going to subtract 5x from both sides. And clearly I don't have enough room here, so I'm going to have to really smush this in. So that gives me 3xy minus y equals negative 2 minus 5x. And I'll just move over to the right here. So now in order to get the y out, because those are not like terms, I can factor out the y, which gives me 3x minus 1, which is then equal to negative 2 minus 5x. And then when you divide both sides by 3x minus 1, you get y equals negative 2 minus 5x over 3x minus 1. Now that we've solved for y, that is our inverse. So this one is a little tricky to solve for y. Once you recognize the trick, then you can solve any of these to find the inverse. But it's not intuitive, especially if you're not, you haven't seen a lot of the different tricks that you can do with algebra. You wouldn't know how to get y out of the fraction. So that's how you do it. Okay, and then this one, I didn't put in the domain and range because we have to restrict the domain. Because of the function. It's not, this g of x doesn't have an inverse unless you look at it over a certain domain, or if you restrict the range in the other direction. So in order to have an inverse, we have to say that we're only looking at x between 0 and 2. So we want to find the inverse. So first I replace g of x with y. So y equals square root of 4 minus x squared. So now I interchange the x and the y. So x equals 4 minus y squared. Now in order to solve, I need to square both sides because we need to get rid of that square root because we're trying to get y outside of there. So I need to square both sides. So that gives me x squared equals 4 minus y squared. So I need to get the y by itself. So I'm going to subtract 4, which gives me x squared minus 4 equals negative y squared. Now I need to divide both sides by negative to get just y squared. So that becomes negative x squared plus 4 equals y squared. Now we're going to move over. Now I need a y, not a y squared, so now I need to take the square root. So I need to take the square root of everything in order to get y. And we get y equals the square root of negative x squared plus 4. Now we do get a plus or minus when we take the square root, and the question is, well, how do we know? Do we want the plus version or the negative version? So now we have to look at our domain here. So the square root function, if we know our parent functions, looks roughly like that. It's going to look a little different because the 4 minus x squared, but that's fine. So in order for this to be inverse, then the inverse is a reflection, where it's going to look something like this. Basically, our x and y are flip-flopped. So if our x is positive here and our y is positive, when we flip-flop, we're still looking at the positive part. So we're going to want just the positive part of the square root. So we just want the plus, and so we're not going to care about, I'm trying to erase it. There we go. We just want the positive side. And then I'm going to replace that with our symbol. So we have f inverse of x equals square root of negative x plus 4. So I'm going to try to bring up a graph of that so that you can see how that works. And I'm actually going to graph y equals x because that's our line of reflection for inverses. So I'm going to just make that dotted. Okay, so our graph, we had the square root of x squared minus 4. Let me just double check. 4 minus x squared. Okay, it'd help if I had those reversed. Square root of 4 minus x squared. Okay. So I said that the square root is sort of like a kind of curves up. You can see it does, and then it comes back down. So that's what happens. The x squared inside the square root, that's what's making it look slightly different from a normal square root, where it's just heading up to the right. So we have this doesn't pass the horizontal line test. That's why it says just from 0 to 2. So we only want the 0 to 2 part. So if we want a reflection, actually, if you ignore the negative 2 to 0 part, it looks like a mirror image already. So it looks like you're going to get the same exact function. And that is actually what we got. It's its own mirror, because we got negative x squared plus 4, which is the same as 4 minus x squared. So we want the positive version. If we had put in the negative version, we would have had it upside down, and then it wouldn't be a reflection anymore. I'm not really sure how to... I know there's a way to restrict the domain. I just don't know how to do it. Now let me take a look at our example 2 and graph that one, just so you can have an idea. So I've got x minus 2 over 3x plus 5. X minus 2 over 3x it's plus 5. Okay, so you can see it roughly matches the picture that I drew. And if I want to reflect over that line, I don't have a perfect, it's not a mirror image right now. So we are making a mirror image. So when we solved, what did we get? We got negative 2 minus 5x over 3x minus 1. So now, if you look at it, once you have both the green and the purple in there, you can see that they form a mirror image. So the inverse will form a mirror image across the line y equals x, which is my dotted line. So you can see the mirror image now, and that's how you know they're inverses, because they look like they form a mirror image. And let's go to example 1. So example 1 here, that was the cubic. So we had x cubed plus 8. X cubed plus 8. And then our inverse, that was the cubed root. There's no cubed root button, but that's the same as the 1/3 power. So we had x minus 8 cubed root. So that's a 1/3. So you can see, again, it forms a mirror image across the line y equals x. So that's how you know that those are inverses, is when you look at that line. I'm going to change the color here so just so it doesn't. You can see over the dotted line, there's a mirror image, and so then they are inverses. And that's a way to make sure that you solved it correctly, because if you graph them and they don't form a mirror, then that means you made a mistake. So hopefully I haven't confused you too much with my examples here. The big thing is just being able to do the math, to do the algebra in order to find the mirror image. But that's about it. So that is inverses.